Okay, so now let's go on to question 3. So question 3, I already written the difference already. So do take note, all these differences can actually be found on your page, okay, 60 of the textbook. Okay, so this is literally just copying it from there. But maybe let's draw some difference between mixture and compound to elaborate a little bit more. Okay, so for mixture, do take note. Let me zoom in a little bit. For mixture, one of the differences in terms of it can be seen in terms of the separation. So a mixture can be separated by physical processes. So what are some of the physical processes? You can use a magnet to separate them. You can use filtration. So filtration is like using the sieve at home where, or like you go and eat wonton mee or mee rebus, you realize that when they cook the noodles, there's this thing that they use to get the water away from to like sort of like to get the noodles away from the water, and your noodles are sort of like dry. So filtration is actually about separating the liquid from the solid. Okay, we'll go into that later on in the next chapter. Next one, we also have distillation. We'll look at that process a little bit more in the future. So three main physical processes: magnetic separation, filtration, and distillation. Okay, so mixture can be separated by these three physical processes. Now, how about compound? So compound cannot be separated by physical processes, okay? Cannot be separated by physical processes, okay? Separated by physical processes. It can only be separated by what we call chemical processes, okay? Chemical processes. Now, there's only two of them that you need to know, which is thermal decomposition. It's about using heat. So thermal actually means heat, okay? Decomposition means to break down. Okay, let me rewrite the word breakdown. Okay, so it's about using heat to break down. So thermal decomposition is one of the methods, one of the chemical processes used to break down a compound. The other one is what we call electrolysis. It's about using electricity to break down the compound. So in terms of separation, mixture is normally by physical processes. Compound is normally by chemical processes. Now, in terms of the property, okay, property, what are the difference in terms of the properties? Okay, so the chemical properties of a mixture are the same of those of its component. So example, maybe one simple example would be like a mixture of hydrogen gas and oxygen gas. So hydrogen gas and oxygen gas. Now, when you mix these two gases together, just put them together, okay, without letting them to react. H2 is a gas, O2 is also a gas. A mixture of these two gases is also still a gas. Okay, and this gas can also still have the chemical properties of the oxygen, can also have the chemical properties of hydrogen. So a mixture actually have the chemical properties of its components. However, for a compound, let's say for example, when I put hydrogen and oxygen together and they react, they form this compound called H2O, which we commonly know it as water. So for water, we do know that it is different, okay? It is different from H2 and O2. H2 is a gas, O2 is a gas, but H2O water is actually a liquid. So in terms of the physical state, it's different. In terms of how they react, it's also different. Okay, so do take note, the physical and chemical properties of a compound are different from those of its constituent elements, whereas for mixture, the chemical properties are the same of those of its component. Okay, the third one, energy changes, is really about reaction. So when I form a mixture, generally I'll have no chemical reaction. Because there's no chemical reaction, there's little or no energy change. Whereas to form a compound, a chemical reaction normally will take place. Okay, so because the chemical reaction takes place, there is an energy change. So the things that's reacted may get cold or may get hot. So that's how we talk about energy changes in terms of the heat. Last one, composition. So for mixture, you can mix it in any ratio. Okay, the composition in terms of the ratio is anything, like it varies. Okay, it varies. So what do I mean by that? For example, if I want to mix, once again, let's go back to H2 and O2 example. I can put 50% of this, 50% of this. is a mixture of O2 and H2. Okay, I can also put, maybe once again, still H2 and O2, separate them. Okay, maybe I put 75% of this, 25% of this. This is still a mixture of H2 and O2. Okay, so the components of a mixture can be mixed in any ratio. Okay, so anyhow, any percentage also. Now, however, when we look at the composition of a compound, okay, do take note, it's always a fixed ratio. So for example, if I want to form water, I definitely need 2 hydrogen mixed with 1 oxygen. So it's a ratio of 2H is to 1 oxygen. 2H is to 1 oxygen. Okay, any other ratio doesn't work. Another example is carbon dioxide. Okay, carbon dioxide is also a compound. So we know that it is CO2. To form carbon dioxide, how many carbon do we need? How many oxygen do we need? We need 1 carbon with 2 oxygen. Anything, any more oxygen or any more carbon, okay, it will not, it will no longer be carbon dioxide. It will be a separate or a different compound or mixture. So there are 4 main differences in when we are comparing mixtures and compounds.